Now, what is object-oriented programming? Let us discuss some time about OOPS. What is OOPS? OOPS, an object-oriented programming language. Java is an object-oriented programming language. So, what is it? Is
compare it to the real-time object.
correct.
It will be easy for you to code.
Correct. Very correct. Very true. Any other points?
Each of the entities created some object, and you can interact with the object.
Exactly correct. Very good. So whatever you said is correct. Let me put it in a proper way. C is object-oriented programming language. True or false? It is procedural or structural? Structural. Huh? Procedural language? C is a procedural language. Java is an object-oriented language. So whenever I say object-oriented language, in object-oriented language, what we do is, first we will create objects. And object-oriented programming is nothing but interaction between the objects. But if I talk about procedural language, in a procedural languages, what we do is we define procedures, not objects. Procedure means just a method. And running a procedural language is nothing but calling method calls, procedure calls, right? So what you can do in object-oriented programming language is you can model any real-time entity as an object in your application, and your program, object-oriented program, is nothing but method calls on that object. Not very clear. Didn't get any picture in your mind. So let us talk more about objects. Right? If I define object-oriented programming, the definition will be like this. So definitions will always not be clear. Let us discuss. What is an object? Now tell me. A straightforward question. What is an object? Real-time entity. Something which is existing is an object. I am an object. You are an object. This is an object. Projector is an object. Computer is an object. Everything which you can see and feel is an object. Right? So what I want to do is I want to model an object which is existing as a logical object in my program. Right? So how to model, how to represent an object in my program? First of all, whenever I say this is an object, I have to describe about this object. So what is this object? This is the remote. It is having some 20 buttons inside it. Each button has a functionality inside it. It is some silver in color. It is having some black buttons. Somehow I need to describe it. So whenever there is an object, first of all, we need to describe it. How it looks like. Every object has some properties and some behaviors. Every object has some functionalities and some behaviors. How an object looks like, some is defined by the properties, and what this object can do is defined by the behaviors. So if you take any real-time object, every object, if I take myself, if somebody is asked to describe about me, I'll say I am so and so, I am this much in height and this much in weight, I can do this, I can do that. So whenever an object has to be described, we will always describe how it looks like first and what it can do. Right? So if I have to represent a real-time object as an object in my application, first of all I need to describe it. Right? that description of an object is done in something called as a class structure. Right? Class is nothing but a description of an object at the simply. Right? So again, let me ask you, what is a class? Okay, I just told you a bit of class. What is a class? Class contains object? No. It's a user defined data type? Correct. Any other thing? Blueprint of an object? Correct. Any other definition of a class? Yes, prototype, correct, exactly. So, as I said, let me ask you a basic question. Ganesh Chaturthi we celebrate. In Ganesh Chaturthi we buy some idols of Ganesh. Some small idols, big idols. So the people who are preparing it, do you think every Ganesha is made out of hand? So what they'll do? They'll prepare a structure, or they'll prepare something called as a mask kind of a thing. Right? And then they'll stuff some sand and whatever stuff inside it. They'll take out. Then a Ganesha shape is created. Mold we say. They'll create a mold of Ganesha. Then they'll stuff everything inside. Then they'll take out. They'll get a shape of Ganesha. Then they'll use some painting to do some paint and they'll sell it. So their purpose is what? To create a lot of Ganesha objects, Ganesha idols. So first, before creating Ganesha idols, what they'll do is they'll prepare a mold first. They'll directly not start with Ganesha. So they'll prepare a mold and then they'll start preparing Ganesha, right? So I can say mold is just like a template of Ganesha. Similarly, class is just like a template. So you are going to create, you want to create 100 objects of same type, right? So whenever you want to create 100 objects of same type, you just need to define how it looks like a template. That template is nothing but a class. Class is nothing but a template of how an object looks like. Or class is nothing but a prototype, as it told. Class is nothing but a blueprint, as it told. And class is nothing but a structure, as it told. Right? So you see, you know about structures, right? What is structure in C? Yes, a user defined data type which can be a complex thing containing simple data types. Right? In C, can structures have variables? Yes. Can have methods? In C? No? Sure. Sure? I say yes. Do you agree? No? In C++? In C++, what they did is they used a term called, instead of struct, we use class. In that class we define variables and we define methods or functions also, right? So in the class we can have variables and also, so similarly in Java also, whenever we define a class, we define variables to represent properties which will describe about the object, and methods are nothing but it will tell about the behavior, right? So let's start a simple class and I'll explain you what is happening internally inside the JVM when we create a class and when we create an object, what actually happens inside the JVM. Let's discuss with the simple things. Okay, suppose now I am asked to develop an employee application. I think you have an employee portal in which you can search for an employee. If I ask, I want a person named Shiva, I want a phone number of a person named Shiva, you can go to your portal, and search for Shiva, right? So let's say I am developing an employee database application, right? So I need to represent an employee as an object in my application. Real employee has to be represented as an object in my application. So to represent an employee as an object in my application, first of all I need to describe what an employee has and what an employee does. Right? Every employee will have a name, employee ID, he'll have a salary, some other description. Right? So first let me create a class called as employee. Right click on source and say new class employee. Don't take main now. Finish. Okay. I'll create int employee ID string name. String is a predefined class, and int salary. Okay, let's say these are three things which my employee has, and what an employee can do is represented by a method public void do some work. Every employee will do some work, so just represented system.out.println doing some work. See here, I'm concatenating name plus is doing some work. So I concatenated two strings by using plus. Name is a string and is doing some work. So this is a simple employee class. So what we did was we just created a class called as employee, a definition. Class is just nothing but similar to a structure in C, or class in C++. It has some methods and some variables, right? After we define a class, we can create an object. Let's see how to create an object, and let's try to understand what will be done during object creation. Now I'm creating a new class in SRC, and I'll name it as demo. I'll take public static void main method. Finish. Why I didn't have main here in employee? Because I don't want to execute this class, right? It is just for creating objects, so I don't have main. In some other class demo, I have taken main, and here I'll just create reference of employee E. So tell me, did I create an object of employee? These are why I have created an object of employee, right? Do you agree all? I created an object of employee. True or false? True. Anyone says false? I did create an object of employee. I just created a variable which can hold address of employee object. So this is not an object. I just declare a variable called as E, which can be holding the reference of employee object, right? So whenever I say int I is equals to 10, you might have done this in C. So what is the meaning of this line? Yes. So a memory will be allocated. The memory location will be named I, and inside 10 will be kept. Similarly here, variable E is declared, but E is a part type employee type. So inside this, what can we keep? We can keep address of employee object. Okay. So then after doing that, what I will do is I'll say simply E is equals to new employee. So now I created an object. Okay. In type? For employee. E is a variable. So that means the memory location is allocated. The memory location is named E, and this E can hold address of employee objects. So E is a variable of type employee which can hold address of employee objects. Right? Now I am saying address. But address is not a correct word to use in Java, right? Later I'll tell a name called as reference. It should not use the actual word address. In C actually you have pointers which can hold address of variables, but in Java we don't have pointers. We just call this as a reference variable. It is for reference of employee object. But for our understanding, you can imagine E is a variable which can store address of employee, but it is not actually address. It is a reference.
It is the starting point, mean like it will use 8 bytes, then it will point to the first byte or what?
No, that's what. You should not imagine it like in C. See, in C language, if I create a variable, it will be actually allocated some memory. It will be given the memory address. I can even use that address for incrementing or decrementing the address, and I can manipulate that address also. But here in Java, our program is running inside a virtual machine, which is not the actual operating system. So the address, even though we get the value of the address, it is not the actual address. It is some virtual address. So we should not refer them as actually addresses. We just say it's having a reference, right? It will have some value, but that is not the actual address. By using that value, JVM can understand and can reach that variable. So it is not an actual address, it is just a reference. Only JVM only can understand, by seeing the value inside that variable, JVM only can understand where this object is created. So we don't say it's an actual address, we say it's a reference. Because we cannot manipulate it. Like you see, we can manipulate the addresses also. Here we cannot manipulate. Okay, so when I said new employee, what happens? Okay, now if I run this, just concentrate here. If I run that, first, what happens? If I have to run it from command prompt, what I'll do? I'll do like this: Java demo, right? So what happens is Java.exe will launch JVM. JVM will search for demo in class path, right? Once it finds demo.class in class path, it will load demo.class into memory, right? So actually, memory is divided into logical units. They are not physical units. Memory is divided into logical units like this. If you assume that this is a whole memory, this memory inside JVM is divided into logical units, not physically. Just for understanding, we'll see logical units like this. There are lot of logical units. I'll just tell about the important units. First, this I'll call as heap area. Heap area is nothing but some area inside RAM itself. Heap area. So this is a whole memory allocated to JVM. JVM is it a process? Tell me. JVM is a process. For JVM also memory is allocated. So if this is a whole area allocated to JVM, the memory allocated to JVM is again, I am splitting it into logical areas, heap area. And second one I am naming it as method area. And third one I am saying it as tag area. So let's see what is happening and what is the significance of each of the areas. There are some more areas which are less significant. I am just talking about the important ones which we need to visualize. Okay. Now, when I say Java demo, what happens? JVM starts. Memory is allocated to JVM. This is the memory allocated to JVM, right? Now let me tell about what is a thread. What is a thread? You know about process. Running program is nothing but a process. Or I told steps the operating system has to execute to run a program is called as a process. Then what is a thread actually? Lightweight process. I mean, what is lightweight process? Correct. Whatever I said is lightweight process, but can you just elaborate it? Your steps, yeah, almost. You are also nearby, but no, some more points. You are also correct. I'll put your words in a proper way. Okay. So whenever it says as a as I defined process. Process is the steps to be done by the OS run a program. So if I have to run a program, first memory is allocated, then process tables are created, process control block, a big data structure is created, registers are allocated, lot of things. Right? All these steps together we are calling it as a process. But finally, after allocating all resources, creating all data structures, the code inside my program has to be executed. The code inside my program will be executed by a part of a process. We call that part a thread. Thread is a part of a process whose responsibility is to execute your code. A process will not execute your code. Process, inside process, there is a small part of the process, a sub-process we call it, part of the process. The responsibility of this sub-process is to execute the code. So that sub-process we name it as thread. Thread is nothing but a part of process or sub-process whose responsibility is to execute your instructions in your code. Process will not execute. In every process, at least one thread will be there which will execute your instructions. Right? So if you take any process, not only Java process, any process, there will be at least one thread which is executing the code of your program. Right? So now once I start Java, JVM starts, that's the process. Inside JVM process, lot of threads will be kicked off. Lot of threads. I'll talk about what all different threads will be kicked off. Just assume lot of threads are started. Many threads. We'll talk about all threads in trading part. Now, one thread will be started whose execution will start from main. Here my program is having main. The main thread will start executing main method. Right? Now, first of all, if this main method has to be executed, the demo.class has to be loaded. JVM started, thread started. It has to execute its method. That means before all this, demo.class has to be loaded. Demo.class is having what? Bytecode. Bytecode has to be loaded. Where it is loaded is, it is loaded inside the method area of my memory. So method area contains the class definitions. Right? Class is loaded inside method area. Simple. Bytecode is loaded into method area. Okay. Then next, once you understand this, let me tell you, a main thread is started. Again, talking more about thread. To start a thread, operating system has to do minimal work. To start a process, operating system has to do a lot of steps. But to start a thread, operating system has to just have to allocate memory for a stack. Stack, data structure. Last in, first out data. So if an operating system has to start any thread, the only minimal thing the operating system has to do is to allocate a memory for stack. Every thread has a stack. If in a process there are 1,000 threads, each thread will have its own stack. Right? So every thread will have its own stack. So the main thread also has its own stack. Stacks will be allocated memory inside the stack area. All stacks will be allocated memory inside the stack. You will understand the significance of this stack just after some time. Okay. So when thread started, stack was allocated in stack area. Demo.class has been loaded inside the method area, and then the main thread starts executing the main method. Right? Here what I did, I am creating a reference, and here I am trying to create an object. Then whenever I am trying to create an object, first of all, my JVM has to know how this object looks like. So employee.class also should be loaded. Right? Where is employee.class loaded? Say in method area. All .class files are loaded inside the method area. So employee.class file also is loaded. After class is loaded, JVM came to know in employee class there are three variables: ID, name, and salary. Right? So then it will allocate memory for all the variables inside the employee class. So memory will be allocated inside heap area. Memory for the object, the variables inside the object will be allocated inside the heap area. Right? So after allocating memory for employee, the variables inside employee, then there will be some base address. That base address will be returned. So what is my code doing? I am just saying new employee. Here what happened? Object variables of employee allocated memory. The base address is returned. Where am I storing? In E. So E is having the address of employee, or I say reference of. Right? The object is created. Object is allocated memory in which area? Heap area. Right? In method area, class files are loaded. In stack area, stacks are created. Right? So once you understand about this, okay. So you understood about how object is created, right? Then in employee class, what I'm going to do is I'll just write like this. Is it a method? Constructor, not method.
Yeah, method, but a special kind of method.
This is not a method. If you say something as a method, it should always have a return type. This is not having a return type. If a method is not returning at anything, it should at least return void. You should declare that it returns void. So here there is no return type. So this is not a method. This is called as a constructor. What is constructor? Constructor is a block of code whose name is same as the class name. Constructor is not a method. Constructor is a block of code whose name is same as the class name. Right? But why is this constructor? Immediately after object is created, if you want some logic to be executed, you can keep inside the constructor. So what I will do is I will say syst. Previously I showed you syso. Now syst and control space. That's called a system trace. Just for debugging purpose, we can use this trace so you can understand if this is printed employee.employee is fine. Just for debugging purpose. Okay. Okay. So this is a constructor, and if you want to write any initialization code, you can write it, right? So now here what I will do is I'll just write name is equals to, I'll just keep my name, I'll write Shiva, and I can just give any variable, any value. Employee ID is equals to 1, salary is equals to 1000, something like that. So when is this constructor executed? Immediately after object is created. So if you want to write any initialization code, you can do it inside the constructor. Now just execute this demo. Yeah. See here, I saw the output inside the constructor. So what happened? First, employee.class is loaded. Variables inside employee are allocated memory. That means object is created. So whenever I say see, just imagine, I'll always be using object is created. Whenever I say object is created, you just have to assume that memory has been allocated to all the variables of class. Right? What is object? Memory allocated for variables inside the class we represent it as an object in memory. Right? Tell me, where is the memory allocated for methods? Class having methods also, right? So if we create two employee objects, are the methods loaded twice? The methods are loaded only once during the class loading, and methods are loaded inside which area? Method area. So if I create two objects of employee, two times variables are allocated to memory, but methods are loaded only. Fine. So we understood the importance of constructor. Now I'll call e dot do some work. Okay. So important thing now. What will happen if I run this? It's printing Shiva is doing some work. Why Shiva came here? Actually, in my do something, what I did was I just printed name plus is doing something, some work, right? So how it became name became Shiva? Did I give the value? Just I called e dot do some work. My question, important question which you need to understand clearly here. How is this name replaced? Okay. So I'll do like this. Just tell me your answer now. Employee E1 is equals to new employee. Okay. And E1 dot name is equals to XYZ. Then E1 dot do some work. Now what it will print? XYZ is doing something. Method is loaded only once. But whenever I am calling do some work on E, it is printing Shiva. Whenever I call E1 dot do something, it will print XYZ. Actually the method definition is same. How is it differing? How is the output differing? That is my question. Objects are different. But where is the memory allocated for the variables? Heap area. Here objects are there. E1 dot name is here. E dot name is here. Methods are here. How about these two connected actually? Got my point? Yeah. Variables are allocated somewhere. The method bytecode is loaded here. Whenever I am calling e dot do something, it is picking the value of Shiva from here and printing it. Whenever I call E1 dot do something, it is picking name XYZ from here and printing it. So how are these two connected? So you need to understand one important thing here. Even without understanding here this, you must be doing a lot of programs, but let me tell you clearly. In my method, in my Java code, what I did was, I did like this. This is my method. Do some work is my method, right? In .java file, this is the method. But the .java file is converted to .class file. Bytecode, who is converting it? Compiler Java C. So what the compiler is doing? It is reading .java file and writing .class file. So what this compiler will do is, it will change this definition of do something, right? And it will do something in the bytecode will be like this: employee. This method is in which class? Employee class, right? Employee. This. So your methods in the bytecode will be having one extra parameter, extra argument. The argument type is same as the class type, and the variable name is this, right? And the variables which you are using will be renamed to this dot name, right? So in the bytecode, do some work is like this, but in Java code we don't do like this. In bytecode is like this, right? Now once you understand this, now coming back here into demo, here what am I doing? E dot do some work. This is in Java code. E dot do some work is in Java code, but in bytecode this line will be converted to do some work. Do some work in bytecode takes what? Employee reference, right? Do some work of E. So E dot do something in Java is translated to do some work of E in the bytecode. In bytecode, the reference or the address of E is passed to do some work. So where am I taking it? Inside which variable? Yes. So you are passing the address of employee on which you are invoking the method. Right? So here it is using this dot name. Now is it connected? So you need to understand how it is working. What I mean to say is, in your code, if you write name or if you write this dot name, they are equal. Or in my methods, I am using a variable called as this. Whenever I am using a variable in Java, do I need to declare it? Yes, without declaring, I cannot use a variable. But where did I declare this? This is an implicit object. It is implicitly there, even though you don't declare it. It is there because in the bytecode it is there, right? So it's an implicit object. You can use this. This is an object which represents the current object, an object on which you are invoking the method. E dot do something. Do something is invoked on E. E is passed to do something in the bytecode. So this reference is pointing to the current object on which you are invoking your method. Any doubts? Let me know. Now, one thing is, it is in an object, in a class, I declare the variables as int, string and int, right? If I declare it like this in demo, am I able to access name? Yes. I am able to access the variables of my class directly, right? But some of the methods which I am using is internally using that variable. I might have written some logic. Actually, till now I didn't write any logic. I might have written some logic here, which might be actually depending on the value inside name, right? So outside this class, if you are able to access name and change it, my logic may not work. If you change the name to something else, the logic which I wrote might not work, right? So I don't want to expose that name variable outside, right? So I want to hide it from the outer world. Like if you take this remote is internally might be having a lot of small chips. You are not exposed to all the chips. You are exposed only some buttons. If you are exposed to all the chips, you may turn off one of the chip and expect it to work. Right? You may tamper one of the chip and expect it to work. Right? It will not work. So some of the internal things should be hidden from the outside world. Right? So always it's a good practice to make your variables private, because your logic which you are writing here in the methods might be dependent on the values of the variables, which your logic only should change. Right? So it's always a good practice to make all your variables private. Private means they will be accessible only inside the same class. Outside the same class they will not be visible. There are 4 access specifiers in Java. I'll be talking about all of them slowly one by one. Right now I just introduced private. So now as I made name as private, see here I got error. Name e1.name I am now not able to access because the field employee.name is not visible outside. But what if I want to give access to the private variable? What I need to do is I need to write a setter method like this. See what I'm doing? I will write a public void set name. I'll pass string name, and here I'll say name is equals to name. Is this logic correct? Anyone point out? The variables which you declared inside methods called local variable, and the variables which are declared inside class are called as instance variables. Why are they called as instance variables? Any reason? Instance variables can change. Not modified. if I give a name, initial value for name is Shiva, I can change it to learn anything. So yeah. Maybe partly correct, but let me check. Let me tell you. Here, tell me what is an object? Object is an instance of a class. In class, we are just defining this structure. We make an instance of a class. There's nothing but an object. Here I created two instances of employees. Right? Tell me, each employee object is having name, ID, and salary. Name is allocated memory twice. Name variable is there for employee E object. Name is there for this one also. So 2 times name is allocated memory. So variable name is allocated for each instance. For each instance of object, the name is separate copy. Each object has its own copy of this variable. So for each instance, one copy. So that's why they are called instance variables. Variables for that instance of the class. Right? So the variables which we declare inside the class are called as instance variables. That means if I create 100 objects of employee, 100 copies of these variables will be there in the memory, in different values. So those are called as instance variables, and these values, these are called as local variables. Now, local variable name is same as instance variable name, right? So whenever local variable name is same as instance variable name, here inside this method, if I am using name, it always refers to local one. So here what I am doing, I am assigning just the value inside that to that self only, right? So what should I do? I should say the variable instance variable name should be inside this value. So what I can do is, so I can say this dot, right? This, how come I use this? Because in the bytecode, the first parameter for set name will be employee this. So to distinguish between local variable and instance variable, we use this, right? So I need to give setter method like this, right? So I told it's always a good practice to make all the variables private and give public setter method, right? And if you want to give access, read access, what you can do is you can write public, return type is string, get name, and you can return and you can just return name, right? This is a public and get, public setter and public getter, right? So but there are 3 variables here. If I have to write set name, get name, set ID, get ID, set salary, get salary, it will be difficult for me. I am a lazy person. I want a shortcut. Let's see how to generate these getters and setters automatically. I'll just delete this, right? I want this getters and setters to be automatically created. Keep your cursor inside the class definition, okay, somewhere inside the class definition, outside of all methods, and just go to source, generate getters and setters. Take it, select all, okay. So you got all the getters and setters generated automatically. So this is a shortcut for generating the getters and setters. Now once I made my variables private, right, coming to demo here, whenever I make an employee, new employee, immediately after object is created, what is executed? Constructor is executed, and name is always Shiva, employee is always 1, and salary is always 1000, right? But I don't want like that. Whenever I am creating an object of employee, I want to pass different values for ID, name, and salary. What I can do is I can give another constructor. So what I'll do is, see here, I'll write public employee. Two are having same things, but I'll give a different parameter. Int employee ID, comma, string name, comma, int salary, and here I'll write this dot employee ID is equals to employee ID. This dot name is equals to name. This dot salary is equals to salary, right? So here I have two constructors, one which is not taking any parameters and one which is taking some parameters, right? The one which is not taking any parameters is nothing but we call it as default constructor, and this is a parameterized constructor. Now what I have done is I say I have written overloaded constructors. The constructors are overloaded. What is the meaning of overloading? Tell me. What is overloading? Same name, but different parameters, right? If a method is having same name with different parameters, we say that the methods are overloaded. But are these methods? No constructors. So we say that we have overloaded constructors. So I have two overloaded constructors, right? So which constructor to be called is dependent on the parameters you pass. So while creating employee object, you can pass employee ID name and salary like this. Employee ID 2, comma, name is XYZ, comma, some value. So you decide what values to be initialized by passing it through constructor, right? So you understood how to write overloaded constructor and how to pass values to the overloaded constructor. So overloading means same name but with different parameters. Here I have shown you how to overload constructors, right? Now I have a very basic doubt. What I will do is I will comment. See how I commented? I just wanted to comment this one. So select it and just say go to source, add block comment. So that is commented out, right? So once that is commented out, I have only one parameterized constructor. Now in demo it's giving me error. Why? Because if I just say new employee, it's saying the constructor with empty parameters is undefined, right? Now, excuse me. Now what I'll do is I'll go to employee and I'll just comment this constructor also for some time. Okay. Now going to demo. Oh, here there is no error now. Here there is an error. Why? Is there a constructor which is taking empty parameters? See this code? I commented out this one, right? But that means there is no constructor which is taking empty parameters also. But why is it not giving error? See, this is giving error for me. It is logical because there is no constructor which is taking 3 parameters, right? Here also I am expecting an error. Even in my employee class, I didn't define an employee constructor which is taking empty parameters. That's also I commented. But why is the error not shown here?
Already defined default constructor.
Yes. If you don't define any constructor, the compiler, which is writing dot class file, will insert the code for empty constructor. So in your class, there are no constructors at all. So the compiler, what it will do, it will insert a code for employee constructor, right? But now tell me, now I wrote one constructor, parameters constructor. Will the compiler insert default constructor? No. So if you give at least one constructor, the compiler will not insert the code for default. If you don't write any constructors, then compiler will write default constructor in the bytecode. Right? So if you write your own constructor, now there is no default constructor. That's the reason why I am getting the error here. Now I got error here, right? Because the constructor is undefined, right? So that I want you to understand about default constructor. The compiler will automatically write the code for default constructor if you don't define any constructor.
What is the values for those variables?
Default value for int is 0, default value for string is null. Default values will be there, right? Any other doubts? The next thing, see here carefully, I have a small requirement now. I'll tell my requirement, you have to tell me the solution. Every employee is having employee ID, name and salary. So if in my sys there are 1000 employees, my database of my application will be creating 1000 employees. If you search for name, it gets that many number of employees, right? All the employees in this company will have only company name as same. Let's say I am writing a variable called as company name. Private string company name. I am writing a variable called as company name. Now if I have created 1000 employee objects, how many company names will be allocated in memory? 1000. But company name for all of you will be same. So one variable inside heap is sufficient for 1000 employees, right? So what I want is one variable should be shared with 1000 employees. Okay? Static. So you have to make your variable static. So I'll just repeat. If I make a variable as static, what is happening? Right? Let me just tell you the flow. If I make a variable as static, see the code here. Okay, I'm just uncommenting this line also. Okay, see the line here. See the code here in demo. I'm just deleting it for. Okay. Now I'm creating an object. Is that? First class is loaded. First time whenever you create an object of employee, class is loaded. When class is loaded, where is it loaded, into which area? Method area. Immediately after class is loaded, static variable is allocated memory. Where? In heap only. Static variable is allocated memory in heap only. When class is loaded immediately, right? After class is loaded, I said new. So that means I am saying object to be created. So immediately object is created means what? Memory is allocated for all the instance variables. Memory is allocated for all the instance variables. Then constructor this. Right? Now tell me, if I do like this, with a different value. Now again another object of employee is created, right? Is the class loaded again? When I do like this, class is loaded only once. If class is loaded, static variable is allocated only. That means static variable is again allocated only once. So here in this case there are two employee objects created, employee E1 and employee E2 is equals to two employee objects are created, but two employee objects are sharing the same company name, right? So if you want a variable to be shared by all instances of same class, then you make it static. Then any doubts till now, let me know. Now before I talk about local variables, you understood about constructor overloading. Now I'll do method overloading. See here, do some work. I'll write one more method here, public void do some work, and I'll say string name of work, and here I'll just print this dot name is doing plus So this is a overloaded method, right? Now this is a local variable. Now let us talk about the local variables. When is this code executed? When the method is called, is it? When the control is here inside do some work, this variable is allocated memory, right? This variable is allocated memory on the top of the stack. As I said, there will be a stack for each of the memory, each of the thread. Assume that this is the stack, which I am just drawing. This is the stack, right? When main thread is executing, for main thread we have a stack. So first main thread starts execution from which method? Main method. Are there any local variables for main right now? Args is one of the local variable. E1 and E2 are the local variables. Local variables, variables created inside a particular method are called as local variables. E1 is created inside main, so E1 is local to main. E2 is local to main. So these are local variables. Local variables are allocated memory on the top of the stack. So once a main thread is created, the first method which is executed is main. So when it is here, stack is empty, right? So when the control is here at this line, args is a local variable. So args will be allocated memory on top of the stack. When the control is completed this line, E1 is another local variable which is created. So all local variables are allocated memory on the top of the stack. Right now it is like this. On the top of the stack, this is the top of the stack. Here memory will be allocated for E1 args, okay, and E2, right? Now after E1 object is created, what are you doing? You are calling E1 dot do some work. So the control will go inside do some work. So when it is in do some work, okay, I'll just call do some work and pass some parameters. I have overloaded do some work, right? So I am calling this do some work. So now the control comes inside do some work, right? Here this is a local variable. The local variable is again allocated memory on the top of the stack. So the stack will be added one more element here, right? See, this is the for main and this is for do something, right? So here the value is allocated for, what is it? Name of so when the control is inside do something, memory is allocated here, right? When the control comes back to main, whatever is on the top of the stack will be popped out. The memory will be released. When the control is here again, these variables will be used. So the currently executing methods variables will be on the top of the stack, right? I'll just give an example. Tell me what happens in this case. See, I have a method m. I have a method n. I have a method o. Here I said int I is equals to 10. Here I say int I is equals to 20. And here I say int I is equals to 30. First of all, tell me, will this code compile? Let's assume that these all three methods are like class X. Will this code compile? Sure. Declaring the same variable 3 times. Will it compile? Sure. Same variable can I use again and again, can declare again and again, because they are in different methods. This I is local to this method, this I is local to this method, right? Okay, fine. Now what I will do is I will call from M, I will call n. From n I will call O. Right? Now let us discuss about the stack. Yeah, initially the stack for the main thread will be empty. When it is inside main, the local variables of main will be stored here. E1, E2 are allocated memory here. When the control is inside M, what are the variables inside M? I. So variable will be allocated. It will be named I and its value is 10. From M I called n again on top of that n. So I is again created and its value is 20. From n I called O, and again O I have I, whose value is 30. Right? So inside O, whenever I am inside O, if I refer to I will always be referred to the one on the top of the stack. Right? So inside O, if I print I, it always refer to the one on top of the stack. Right? Let's assume whenever I am inside O, I printed the value I, it prints 30. The control came back to n again, let's say. Inside n, after control came back, if I print I, again I means the variable on top of stack 20. Again here 10. So what is happening is the values of local variables are to be remembered. When the control comes back here, the value of I which is earlier for the method call has to be restored, right? So to remember the value of local variables, threads use stack. That's the main purpose of, I said every thread will be having a stack, right? So why stack? Because in the same thread you must be calling methods. When the method call is done, when the call is going to other method, the values of local variables inside the current method has to be stored. They are stored on the stack, right? So why stack for thread? Why stack for every thread? To store values of local variables. Values of local variables are always stored on the stack. Instance variables are always stored on heap. Static variables are always stored on heap. So understood the difference clearly? Three types of variables I discussed: local variables, static variables, instance variables. How do you initialize instance variables? Where do you initialize instance variables? You have done it inside the constructor, right? Can you initialize static variable also inside constructor? It's a good thing. See, inside the constructor, I'll say company name is equals to that means if I created 1000 objects, 1000 times this code is executed. Same variable, static variable is only one. Same variable is assigned a value 1000 times. Why unnecessarily? Why should this variable be assigned value 1000 times? So assigning initialization of static variable also should occur only once. If I keep it inside constructor, constructor is executed every time an object is created. I don't want. Instance variables initialize inside constructor is fine, right? So what I'll do is, the best way to initialize a static variable is to create a block. This is a block. I'm keeping it and I'm naming this block as static. This is a static block. You can write a static block anywhere in your .class file. definition. When is the static block executed? Immediately after the dot class file is loaded. Immediately, first static variable is allocated memory, then static block. So immediately after a class is loaded, first static variable is allocated memory and static block is executed. So this is the best place to initialize your static blocks. Now, as you have mentioned, you say that you can just say company name is equals to MySys, right? Yes, both are same, but this is discouraged. First thing, and I'll tell you some other scenario. Let's assume that this company name has to be initialized by firing a query to database. In database, company name is stored. So you don't want to assign it directly by after executing some logic. You want to assign. Then you can do that inside stack. Okay? If you want to directly assign, yes, you can do it, but it is not a standard way or good practice. Yes, that's what it's saying, but about good practices, right? Tell me, can you assign a static instance variable also can be assigned? Here also, but it is not a good practice. How to access static variables? See here in demo, I'll just write some code. I just want to print company name. Just want to print company name. I don't want any of the objects created. So what I'll do is system.out.println and I'll say employee dot. Am I able to see it here? No. I'll make it public. Public means it is visible everywhere. First, I'll make my variable public and I'll say employee dot company name, right? So did I create any object now? No. Static variables are loaded when class is loaded. So in this case, what happens? I'm trying to access a variable of employee. So at this time, class is loaded. That means static variable is allocated memory, static block is executed, then this will be. So what I mean to say is, to access static variable, you need not have objects, because static variable does not belong to any particular object. Okay? So you can access static variable by using class name, right? Now, tell me if this is a good code. Employee E is equals to new employee, and I'll say E dot company name. Is it okay? Yes, because static variable is shared by all objects. Every object will feel that it is its own variable. Yes, you can access a static variable also by using reference variable, but it is not a good practice. It's always recommended to access static variable using class name. Right? Understood about static variables, static blocks. Tell you I want to write one method public void get company name. So public string get company name, and I'll just say return company, right? So what I'm going to do is I'm I'm going to make my company name private. Will it be accessible outside? So it's giving an error here, right? Now if I want to access that value, how to access? If I want to call this method, how do I call this method? Using object. So to get a company name, I don't want an object to be created, object of employee to be created. Without an object, I want to call this method. So if you want to do that, you can make this method static. If you don't make this static, you have to call this method on an object, because if you don't make this static in the bytecode, what is the parameter? What is in the bytecode? Is this method taking any parameter in the bytecode? It take this employee this, right? It will detect this. So you have to call this method on a particular object. Otherwise, this will not be passed, right? If you want to access a method without an object, you can make this as static. Then what I can do is, if I want to print a company name, I can say employee dot get company name, right? So when to make a method as static? If you want to call a method without an object at all, directly by using class name, then make it. So this method should not access instance variables. Do you agree or not? Suppose system.out.println, just for demonstration, if I try to access name, why is it giving error?
Only static variables.
Yes. Suppose if this is allowed, let's say there are 0 objects of employee and I am calling this one class name, static method. Name belongs to any particular object. Name of which object? There are 0 objects. Inside of static methods, you cannot access instance variables. Right? There will be no meaning, because static methods can be called without an object also. So if you are using an instance variable that does not have any sense, so inside your static methods, don't use instance variables. It's a compilation error. Now the reverse. I just try to print company name here. Will it work? Inside a non-static method, I am accessing static variable. Company name is static variable. Yes, because every object feels that it is its own variable. Yes, this is possible. A non-static method can access static variable, but a static method cannot access non-static variables. So once you understood about static method, why do we declare methods as static? You have a reason now. If you want to call a method without any objects, then you can make it method as static. Now tell me the reason why main method is static. You got the reason? Who is actually invoking the main method? Main thread. Right? Just to call that method, why to create an object of demo class? Not actually required. Right? So without object creation, main thread wants to invoke main method. So that's why we are making the method main as static. Right? Without object creation, we want the main method to be called, so that's why we make the method static, right? What if I don't make main method as static? Will I get any errors? No compilation errors, but if I try to run it, what will happen? The main thread will try to see if there is any static main, right? He will say main not found. This is not a compilation error, but we will not be able to execute this demo. Now, you know about private, public. If I make a variable as private, can it be accessed outside the class? No. If I make a method as private, can it be accessed outside the class? No. Public? Everywhere. Now I have a question. Coming to employee.java, I have two overloaded constructors. One which is one is default and one is right. For some time what I will do is I will comment this constructor. So now here there is only one constructor. I can make this constructor private. Is it or not? Can I make a constructor private? Interesting thing. Will that be a compilation error if I save? Will you see any compilation error? No. Okay, I made a constructor private. See here in demo I am getting an error. Why? The constructor employee is not visible. So I have created a class. What is the purpose of creating a class? So that I will be able to create objects later. That's the only purpose. I create a class. I am not able to create objects. So what is the use of making my constructor private? Got my point? If I make my constructor as private, it is not visible. I cannot create an object. What is the purpose of a class without object creation? So this is it. Here, I want an object of employee. Tell me, is there any other way to create an object of employee? I will write one method, public, return type is employee, get instance, and I will say return new. So create an object of employee and return it, right? So I am able to create an object of employee in same class, right? Will this work? In my demo, I want an object of employee. How do I get it now? Okay. How to call get instance? E dot get get right. If I call get instance, it will return me an object. But to call get instance, I require an object. The chicken and egg problem. Chicken first or egg first? Object first or this method call first? Tell me, how to solve this problem now? Correct. So make this very method as static. So you can call this method without an object. So here in employee, what I will do is I will just call employee dot get instance. Right? Got it? If I call this static method, it is returning an employee object. I can now use this employee object. Right? So that is the logic. Now, once you understand this, again a small improvement on the same requirement. How many objects of employee can be created now? Can I create 10 objects of employee? This is E1. How many objects of employee are there now? 2. Now what I want is maximum in your application there should be only one employee object. There should not be second employee object. Even though you call get instance 2 times, this get instance method should return the same reference. So whenever you call get instance, one object of employee is created, right? Same reference should be given to E1 and E2. E1 and E2 should be pointing to same instance. Right now, E1 and E2 will be pointing to two different instances in this right now. How to make sure that E1 and E2 will be pointing to same instance? At any time in my application, there should be only one object of employee. So what is the problem? If I call get instance, here I am just creating new. So every time I get instance is called, new object of employee is created and returned. Right? So I don't want to create an object of employee in this method. Right? I want only one object to be created. Tell me, which code is executed only once in employee? Right? So here if I can create an object of employee, I will return the same reference always here. See the logic? I'll create private employee E or instance I'll say. Okay? And here I'll try to say instance is equals to new employee. Right? But why am I getting error here? Static block, inside static block, can I use instance variable? No, the variable has to be static. So I'll make this employee as static, right? Then here in static method, instead of returning new employee, I'll just return. So see here, what happens? First, how many times is this employee dot class file loaded? So this variable is allocated only once. This is executed only once. So instance is a static variable which is pointing to employee object. So it is executed only once. Now here whenever I call get instance on static method, it will be returning the same address. Right? So now in this case of my demo, here I call employee.getInstance two times. So same reference is written for both. Right? So if you make your constructors private, you will be having the control. The person who wrote this employee is you. You will be having the control of how many objects can be created. Right? Now if you want to restrict object creations to only one, yes you can do it. Right? Such a class which contains, for which, such a class for which only one object can be created is called a singleton class. Right? So employee class is now a singleton class. Okay? Singleton is a design pattern given by some experts. Singleton is a design pattern. Sometimes in our applications there might be some requirements where only one object of your class should be created. Right? The object might be too costly. If your objects are created, any number of objects are created, your application may become too slow. For sometimes in your applications you want only one object of the object to be created. So in that case we can make our class a singleton. To make your class a singleton, the first technique is make your constructor private. If your constructor is public, n number of objects can be created. The first thing to make your class a singleton class, first thing is make your constructor private, right? And then write some logic like this which will return the object. Singleton. I think on day 6 we will be talking about some design patterns, some good programming practices, design principles we will be talking. Singleton is again, I will talk about singleton there also. Singleton is a design pattern. What are design patterns? See, there are a lot of people who are working on Java from years and years together. Not only Java, any other object-oriented programming. So they might have done a lot of mistakes in the design of their applications, and they might have learned out of their experience. They might have learned, if your application is created in this particular way, if your design is like this, then it is the best design. So out of their experience, they have developed some design pattern. They say if this is your scenario, design your application like this, then you give you best performance. So there are a lot of design patterns. There are some 16 design patterns in Java, core design patterns, right? Out of the expense they have designed, singleton is one of the design patterns. Any doubts still now? How you understood how to create a singleton class? Make private constructor, make a private static variable of same class type, initialize that variable inside static block, and return that next static. These are the steps to be done for a singleton class.